So here is the determinants of healthcare satisfaction identified by research conducted in the past. A random forest is different from a decision trees because the random forest procedure averages all the decision trees. But all these decision trees conducted, they don't include all the factors we saw earlier on healthcare satisfaction. All the decision trees conducted, they only included certain factors on healthcare satisfaction. And the random forest averages all these decision trees that are conducted based on a subset of the determinants of healthcare satisfaction. For instance, we want to assess healthcare satisfaction of people living in different cities in the US. So, in city number 1, we send out a survey that only asks the respondents to rate and rank these factors related to healthcare satisfaction. Then we send a different survey to those living in city number 2 and ask them about their opinions pertaining to these factors: driving distance, waiting time, Medicare coverage, Medicaid coverage, ease of finding a doctor, on healthcare satisfaction. And then we send yet a different survey to those living in city number 3 and we ask them how having HMO, how having dental coverage, how having Medicaid coverage, how having prescription drugs coverage, how being able to afford healthcare affects their healthcare satisfaction. And we can send surveys to people living in cities number 4 to cities number 99 on a subset of these factors related to healthcare satisfaction. And then we do decision trees based on results we find or data we gathered for city 1. We do another decision trees based on the data we gather for city 2. We do another decision trees based on the data collected for city 3, and so on and so forth. Then we average all these decision trees being done on all these cities. This is the idea behind a random forest procedure. We can also think about the concept of the random forest in a slightly different way. And let's say we have a big pool of potential respondents and we divide our respondents into different subsets. Let's say we divide our respondents into 100 subsets and we send different surveys asking their opinions on what affects their healthcare satisfaction on different factors in different subsets. And then from the data we collected in each subset, we do a decision trees for each subset. For instance, for respondents assigned to the first subset, we send a survey that asks them how having their preference taken into account, how having Medicaid coverage, how having long-term coverage, how having prescription drugs coverage, how having affordable healthcare affects their healthcare satisfaction. For respondents assigned to the second subset, we send a different survey asking them how the driving distance to the healthcare facilities, the waiting time to see a doctor, how having Medicare coverage, how having Medicaid coverage, how with the ease of locating an appropriate physician affects their opinions pertaining to healthcare satisfaction. And we send a yet different survey to respondents assigned to subset 3. We ask them how having HMO, how having dental coverage, how having Medicaid coverage, how having prescriptive drugs coverage, and how being able to afford healthcare affects their healthcare satisfaction, and so on and so forth. We continue to send different surveys for respondents assigned to subset 4 until subset 100, with data collected for each subset. We do a decision trees for data collected on each subset, and we average all these decision trees. And this is the idea behind a random forest. And we can either average all these decision trees that includes different factors related to healthcare satisfaction, or we can take something like a majority vote on all these factors related to healthcare satisfaction in each decision trees to arrive at a random forest. Hope I'm making sense here. So, when we average the different decision trees assigned to different segments of the data, or we take a majority vote of people's ranking pertaining to different determinants of healthcare satisfaction, these will give us a more robust and accurate results because it gives us a more generalized solutions. And we can also circumvent the problems related to overfitting when we average or take a majority vote of all the decision trees we collected. So, this is how random forest works. It first takes a subset of the data, then it makes prediction based on the non-selected data points. And by doing this, extreme values can be smooth, and because of that, this can overcome overfitting when we do our analysis. So this implies that random forest may be better than doing a single decision trees because the random forest average all the decision trees we conducted or take a majority votes of all decision trees.